Hello everyone. In this video we are going to find the infinite sum from n equals 2 to infinity with the zeta function over 2 to the power of n. And as we remember, the zeta function is defined as the infinite sum from k equals 1 to infinity 1 over k to the power of n. And let's write out of the expression and see if we can look for some pattern. And for the first term, we are putting n equals 2 into the sum, which is 1 over 2 square, and then we multiply with the zeta function, which is 1 over 1 square plus 1 over 2 square plus 1 over 3 square plus dot 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 to infinity. And with the second term, we have 1 over 2 to the power of 3, 1 over 1 to the power of 3 plus 1 over 2 to the power of 3 plus 1 over 3 to the power of 3 plus dot 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 to infinity. And then let's write out one more term plus 1 over 2 to the power of 4 multiplied by 1 over 1 to the power of 4 plus 1 over 2 to the power of 4 plus 1 over 3 to the power of 4 plus dot 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 to infinity. Okay, let's find out some pattern in this infinite sum. And we can see that there is a 1 over 2 square multiply into the first term, which is 1. And we have the same pattern in the second term. We have 1 over 2 to the power of 3 multiplied by 1. And we also have the same pattern for the third term. So we can, putting them together, we have the first summation which is 1 over 2 square plus 1 over 2 to the power of 3 plus 1 over 2 to the power of 4 plus dot 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 to infinity. And this is the first term of the pattern. So let's see what's the second term is about. The second sum is 1 over 2 to the power of 2 square multiplied by 1 over 2 square. And then for the next term is 1 over 2 to the power of 3 multiplied by 1 over 2 to the power of 3. And then for the third one, the same pattern, 1 over 2 to the power of 4 multiplied to 1 over 2 to the power of 4. And so we can express them as 1 over 4 square, because we have 2 square multiplied by 2 square plus 1 over 4 cube. And then we have the third term, 1 over 4 to the power of 4 plus infinity. And let's see what's the third sum about. And we can see that the first sum is the 1 over 2 square multiply into 1 over 3 square. So we can extract the base, and we can write them as 1 over 6 square plus 1 over 6 cube plus 1 over 6 to the power of 4 plus dot 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 to infinity. And then we have the similar pattern with the base as the even number. So now we know that we have infinite term, the infinite sum, which is with 2 as the base, 4 as the base, 6 at the base, and so on and so forth. So we can use the sum to infinity for the geometric series. And we have the first term, which is 1 over 2 square. We can write it on the numerator, 1 over 2 square over 1 minus the common ratio, which is 1 over 2, plus, for the second sum, 1 over 4 square over 1 minus 1 over 4. And then similar for the third term, 1 over 6 square over 1 minus 1 over 6. And then so on and so forth. So let's simplify this expression. And we know that it is equal to 1 over 2 plus. And for the second term, we have 1 over 16 divided by 3 over 4, which is multiplied by 4 over 3, and we have 1 over 12. And then for the third term, we have 1 over 30, and then plus dot dot dot. And we notice that this sum is exactly multiplied by the consecutive integers. And for the first term, we have 1 over 1 times 2, plus for the second term, we have 1 over 3 times 4. And for the third term, we have 1 over 5 times 6, so on and so forth. And so, for this kind of fraction, we can split the fraction into 2 parts. When for the first one, we can do like 1 over 1 minus 1 over 2. And for the second one, we can make it as 1 over 3 minus 1 over 4, plus 1 over 5 minus 1 over 6, plus so on and so forth. And for this alternating side with 1 over n series, we will use the Taylor series for natural log of 1 plus x, which is divided as 1 minus x squared over 2 plus x cubed over 3 minus x to the power 4 over 4 plus so on and so forth. So now if we put like x equals 1, then we have exactly the same sum. So finally, we obtain the sum as natural log of 2. And I hope you guys will like this video. Please subscribe to my channel, and we will see you in the next video. Thank you. Bye bye.